Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the first episode in a new series, which is the font rendering series. So in this episode, what we are going to be doing is generating bitmaps that we will then use to draw fonts to the screen. So font rendering is a huge topic with several different things, and we're going to explore three main methods of rendering fonts on the GPU, which are traditional font rendering. So just sending a bitmap to the GPU as a texture and then sampling from the texture. Then there is SDFs, which are signed distance field rendering. This preserves quality, but at a drawback of having a longer pre-processing time. And then lastly, we're going to take a look at Bezier curve data and using that directly from the TTF file to generate the fonts. So let's see how bitmap rendering works, and then we will actually generate our bitmap. All right, guys, so the first method of font rendering we are going to be discussing is bitmap rendering. Now, to be clear, when I say bitmap rendering, what I mean is we will be generating a font texture that looks like this. And you should see an image of exactly, a font texture that we will be generating by the end of this tutorial looks like right now too. And basically we just jam all of the different glyphs into this font texture. Then we extract glyph information over to here. And we'll have to talk a little bit more about this in the future too. But for now, we're going to keep it super simple and say that a glyph is just any character and that character contains a minimum and a maximum, where the minimum is right here and the maximum is right here, located on the actual texture itself. So all the values will be normalized between the range 0 to 1, and this will be 0 and this will be 1, just like texture coordinates, right? So that you end up with 1, 1 in the top right corner, 0, 0 in the bottom left corner. This way, we can sample from this texture by just uploading this to the GPU and then telling the GPU, hey, we want to display the texture coordinates right here. And then the GPU will basically sample the character at that coordinate and put it on the screen. This will also give us information like the width. We can just subtract these two to get the width and subtract these two to get the height. Now, this will not be the exact width and height of the characters. There are different things in font rendering, things like kerning, which basically means if you have an F next to an L, you can actually put those closer together than certain other characters. Like if you had an F and I don't know, maybe like a D, you'd have to space these out a little bit different too. And so kerning is the process of examining which characters are next to each other and deciding how close together they should be, which is all embedded within the font itself. For now, we're just going to take it super simple, create a bitmap, and then literally just sample from here and take these values to give us an approximate width and height. Now, I keep talking about just generating a bitmap. How the heck do we generate a bitmap? Well, in Java, we can use the buffered image API. So we'll create a buffered image, and we basically just want to figure out how big of an image we need to make to put all of the glyphs in there. Now, for font or for textures on the GPU, we typically want to keep them a power of 2 or at least square, okay? So like you commonly see 1024 by 1024, 2048 by 2048, which is 1K textures, 2K textures, 4K textures, etc. You don't necessarily need to have these exactly as a power of 2, but it is good to upload something that is more square to the GPU. The GPU does not like very long textures. It would prefer more of a square texture. So if you had something either this way or this way, it's not really going to like that. But if you have something that's more like this, where it's fairly square, the GPU is happier with that. It can allocate memory a little bit better. How in the world do we calculate what the best width and height would be? Well, the first thing we can do is we can just get the number of characters available. So we'll basically say how many glyphs are in this character set, which the font will give us. And so say it says that the glyph consists of 78 characters. Then what we can do is we say, okay, we have 78 characters. Let's just take the square root of that and round this to the nearest whole number. What that's going to give us is 8, because the square root of 64 is 8, and this is the nearest whole number. We floor it. Then we just add 1 to this, which gives us 9. All right? So basically what we're saying, because if you think about it, the square root is saying, what 2 numbers would I need to make a square given this amount of things? And then what we're doing is we're saying we'll overestimate a little bit and give it 9. So basically, if we have 78 characters, then we will allocate a grid that is 9 by 9. Except we can't say it's just 9 by 9. What we have to do is get a little bit more of an accurate estimate. So when the user supplies the font size in pixels, say they say 32 pixels, we'll just multiply this by 32. Then this will give us a little bit more of an accurate size, but it still won't be completely accurate. We can't just use this 9 times 32 because we may end up running over on this side or on this side. So we have to do some calculations beforehand and calculate exactly how large the texture will be. And then we can just sort of draw everything onto the texture. So once we get that approximate length, what we do is we literally just loop through all of the available glyphs, okay? And so the way I did this specifically is I start off saying X is 0 and Y is the line height. So in other words, we're starting off like right here, okay? If this were to be the line height, say this was 32 pixels down, okay? Well, that means then that we would say, let's pretend we're drawing A right here. So we draw A, then we increment X by the exact width of A. So then we'll get the actual width of A and we'll increment X so that we are now here. So then say X is now like 24 or something. It's not gonna be exactly 32 pixels, but it'll be something close. Well, we'll continue doing this until we say, is X greater than or equal to that proposed width that we had done. So like the estimated width, right? Which was just the square root times +1 times the font size. So we'll say that's our estimated width. And then if X is greater than or equal to the estimated width, so let's say we end up with P over here, except P is actually a little bit over the buffer size. And so it ends up right here. Remember, we're not actually drawing onto the buffer yet. We're just trying to get a calculation. What we'll say is the actual width equals the maximum of X plus whatever letter we're currently on, or the estimated width, which I'll just do that. It's an arrow for estimated width. Okay, so basically what we end up saying is, okay, we'll leave the width as this, but if we are greater than or equal to the estimated width, we'll actually move it to whatever's bigger. If it's this, we'll keep it there, but if it's this, we'll move it here just so that we have enough space when we actually create our image. And then we'll say Y plus equals the line height, which will move us down to the next coordinate. We will continue to do this until we get all the glyphs. And then we can do the same thing for Y too. When we add to the line height, we can say if Y is greater than, we'll take the maximum of either if the letter goes slightly below. So say we're on the character 5 and it goes slightly below, then we'll take this as the new height. Once we loop through all the glyphs and do this, we have the actual width and we have the actual height. And as we're doing this, we're also going to create information, which is basically the source X and the source Y. So we'll be creating, this is X is located at 0, 0. And then if we had B, then we would say B is located at like, I don't know, this could be 0.1. And this would be same Y. So we basically just calculate the values for all those coordinates as we're going through. And then once we get the actual height and we get the actual width, we can go and really create this image, except if we have to expand a little bit, that's fine. Then we use the data that we recorded about all the glyphs and we actually draw them onto the image. So then we just go through and we draw every single letter where it should be until we loop through all of the glyphs. And then what we're left with is a buffered image that contains all of the data for all of the glyphs, which is exactly what we're looking for. So once we finish all of that, we can just either export the buffered image or we can upload it to the GPU. And right now what we're going to be doing is we're just going to export it. And then the next tutorial, we will upload it to the GPU. So let's go ahead and generate this bitmap now. All right, guys, so I just have IntelliJ's new project creation window open up here. I am going to go ahead and create a new project for the font rendering solution. So the group ID, I'm going to leave blank, and then I'm just going to call this font rendering. And then we're going to leave it as font rendering, and I have mine in C, dev, Java, then I'm going to say new folder and call that font rendering. Cool. And that should be good for me. Then I'm just going to hit finish and create that new project. All right, so now that we have this new project open, I'm just going to go into the build.gradle file, and we need to generate a Gradle file. So go into Google, we'll type in lwjgl.org, and I'm going to go ahead and go to download, and then I'm going to hit customize, and we're going to go with the release, which should be fine, and we'll say Gradle is the build we are working with. I am on Windows x64. If you're on a different system, then you switch that system. And then just make sure you have minimal OpenGL checked, which has async, GLFW, OpenAL, OpenGL. We won't really need OpenAL or async, but it's fine to have those. OpenGL and then STB, which we will be using as well. And then make sure to check JOML right here. This is the Java Open Math Library, which will be helpful for us. Then I'm going to go ahead and copy all of these dependencies, go back into the IntelliJ project, paste it over this, and then we'll go back in one more time, and then make sure you copy these variables, which we need as well. Go back into here, paste those right above that, and we should be good. Then hit import changes to import all these changes. And let's go make sure that we can actually use these. So we'll go into Java, create a main class. We'll say public static void main string args system.out.println new vector2f. Cool, it imported it. So we do have JOML, and I'm just gonna do 0f 0f. Then go up to run, then hit main. And if all went well, we should see this 0.00e. Okay, so that means we have everything working perfectly fine. Let's go ahead and create the actual font rendering stuff. Now we'll go and create a new package. We'll call this fonts. And then inside of here, we're going to create a new class. I'm going to call this C font, C for Cocoa, just because of Cocoa engine, and we cannot use font, otherwise we'll have namespace collisions. We're going to go ahead and create another new class, call this char info for character info, which will hold like those X, Y coordinates for the variables, for the textures. Okay, so if somebody wants to create a C font, then they will pass in a string, which is a file path or font name. I think this will work either way. And then we will also take in int font size, and we may take in a char set in the future, but for now, we'll avoid that. Then we're going to go ahead and store that file path. And we are also going to store that font size, just so that we can keep track of those. So we'll say this.filepath equals file path, this.font size equals font size. And then we're going to say generate bitmap, which is a function we will now create. So we'll say public void generate bitmap, and this will basically go through and create that bitmap for us. So like I said, we need to create a buffered image. We're going to create a fake buffered image first, and we'll call this just image, imga, and then we're going to call this a new buffered image. And if we look at the parameters, this takes in a width and a height, which we're going to set to 1, 1, and then the type we're going to set to buffered image.argb. So we want alpha, red, green, blue, which should be fine. Hit Alt Enter. Oh, and this should be type int argb. Okay, so that lets us know that it's an integer for alpha, red, green, and blue. Anyways, the whole reason we're creating a fake one with width 1 and height 1 is so that we can get a graphics context. The graphics context will allow us to get font information. So we will dispose of this image after we calculate the actual height that we need. So first we have to create a graphics 2D context. We'll say graphics 2D g2d equals imga.createGraphics, and then we'll say g2d.set font, and we are going to set it to the font that the user has passed in. So we'll say font equals new font, and if we look at that, it takes in a name, which we'll pass in the file path for, and then it takes in a magic style. So just do font.plain, and then the size, which is our font size. So we'll just pass in font size as well. Okay, and then we'll say set font to that font, and I'm gonna just move this up to the above the creation of this code, and I'm gonna say create fake image to calculate to get font information. Okay, so we have created a fake image, gotten a fake graphics context. Now we can say int estimated width equals, and then we're going to go ahead and say int math.square root, just like we talked about, and then we can get the number of glyphs just by saying font.get number of glyphs times font.get size, and then we are going to add 1 to that. So like I said, this will just calculate the closest width that we can get and then add 1 to it, just so that we have a good round number to give us sort of a square-ish image. Okay, one other thing I forgot. Let's get the font metrics, which I think we might need. So we'll say font metrics equals g2d.get font metrics. We may need that in just a minute. Okay, anyways, and then what we're going to do is we're going to say int width equals 0. So this is the actual width. Int height equals 0, the actual height, which we'll just initialize to 0, 0 for now, and we'll adjust that as we go through. And actually, let's initialize this to font metrics.get height, and this should get us the line height of the font metrics. And then we're also going to go ahead and say int line height equals font metrics.get height. I was debating this, but let's go ahead and pull these out into some private member variables as well. So we'll say private int width height line height, just so that we have those available for future use. So just delete that, and then we have width, height, and line height now as actually part of the class itself. Okay, and then we're going to say int x equals 0, int y equals font metrics dot get height times 1.4f. And we have to cast this to an int. And the reason that I am multiplying by 1.4f is just because this was like the best sort of adjustment. So when you have a font, say like you have the letter Y, right? The baseline is right where that intersection is, like the V portion of the Y is where the baseline is at. And then I think what happens is you get, when you say font get height, what that's giving you is the line height from the base of Y to the top. And it doesn't account for that little bottom portion. So 1.4f was what I did, and it works fine. You can probably get the exact number, but I wouldn't worry too much about that. Next, we are going to loop through all the glyphs and calculate what the actual width of the image has to be. So we'll say for int I equals 0 until I is less than font.get number of glyphs I++. And then we're going to say if font.canDisplay I. What this basically does is it says if we can display this code point I, then this is a character that we can actually draw. So that's basically all that means. And we're going to go up to here and create a map, which we will need. We'll say private map from int or integer to char info. And this will be our character map. And I'll hit Alt Enter for that. Then down here, we'll just say this dot character map equals a new map. We'll say a new hash map. I can't remember if that's important or not. Yeah, we'll say it's a new hash map because this is an interface. Okay, so we have a character map, which is where we're going to put information about each of these characters. And then we basically say, okay, if we can display this code point, which is, right, all characters have a code point. So A is 65 or 66. I think it's 66. Capital A is like something different. Okay, capital A might actually be 66. But basically, each of those is actually a number, which is why we are displaying it as, we're saying, can we display this number instead of can we display this letter? Okay, then we will get the size for each code point, glyph, and update the actual image width and height. Okay, so we'll do exactly what I said we would do. We'll create char info, and this is going to equal a new char info. We're going to give it x, y, and we'll just give it the standard x and y for now, and we'll adjust these in the future. And then we'll give it font metrics.char width I and font metrics.char width I, or sorry, .get height. And we do not have a constructor for this, but basically let's go into char info and create that real quick. So char info is just going to contain a public int source x, public int source y, public the width and the height. And then we'll just have a constructor. So then if we just hit code, generate constructor, and I'm going to select all of those, then we'll hit OK. There we go. We get our constructor, which is nice. And it moved this variable, which I don't like. Okay, cool. So we will modify this in the future, but for now, this is fine with me. We just sort of have all of the source x, source y, width, and height of the character, which we pass in right here. Okay, so once we get that char info, we want to add this to our map. So we'll say a character map.put, and we're going to give it the integer I, and we're going to give it this character info. which will help us out in the future. And then we will say width equals math.max x plus font metrics dot char width of the character we're currently on, or width. Like I said, we will just take the whatever's bigger, the current width, or if this character goes a little bit out of bounds, we'll take that width instead. And we'll say x plus equals char info dot width, because we can. We don't have to calculate again. And then we will say if x is greater than estimated width, then we want to move to the next line. We'll say x equals 0, y plus equals font metrics dot get height times 1.4f. And we'll say height plus equals font metrics dot get height times 1.4f. All right, so we basically just increase everything one more to move to the next line. And when we set x equal to 0, that means that the next time we go through the loop, we should be displaying that perfectly fine. And that should be it. This should calculate the actual width and height that we need. We're going to do one more thing here, though. We're going to say, actually, yeah, that should be fine. So this is good. So after we finish this for loop, what we want to do is calculate the actual texture coordinates of all of those characters. So we're going to go ahead and say, first of all, g2d.dispose. So we're going to get rid of that image because we don't really need it. Then we will create the real image, or the real texture. So we'll say image equals new buffered image. Once again, we need the width and the height, which we have as width height, which are the actual width and height now. And then we also need buffered image.type int argb, just so that we have the same type. Then we'll say j2d, once again, equals image.createGraphics. So we create a new graphics context. And then we're going to go ahead and set a couple rendering hints. We're going to say set rendering hint. And we want to say rendering hints dot key anti-aliasing. We want anti-aliasing on. So we'll say rendering hints dot value anti-alias on. That way we force it to anti-alias all this stuff, which is good. Makes it smooth. We'll say g2d.set font to the font that we have, and g2d.set color to white. So I think that's just color.white. Oh, and that's set composite. We should say set color. Okay. And then we're going to actually draw everything onto this image now. This image should anti-alias everything we draw onto it. So we'll say for int I equals 0 until I is less than font.get number of glyphs, I++. That's important. And then we'll say if font.canDisplay I. Then the first thing we're going to do is we're going to say font map, or character map, dot get, and we're going to give it I. And then we're going to say dot calculate texture coordinates. So then we'll go into char info and create a new function. We're just going to call this public void calculate texture coordinates. And then inside of here, we will very simply get these out of the minimum, or the overall width and height of the font. So we'll take in font width and font height here, just so that we can map the source X and source Y to a 0 to 1 range, right? We'll go ahead and store the texture coordinates as an array of vector 2f, just because we can, I guess. So, and then we'll call this texture coordinates, and this is an array of length 4. And we actually have to go equals new vector 2f 4. There we go. Can't remember my Java syntax, and I'm actually going to declare this over here because I just think that makes more sense. Okay, cool. So we have an array for texture coordinates. Then we'll go ahead and calculate x0, x1, y0, y1. So like all the different things that we would need. So we'll say x0 equals, and let's actually make this a float. So float x0 equals float source x over float font width. And we'll say float x1 equals float source x. Actually, we want to do source x plus width over float font width. And then we'll say float y0 equals float source y over float font height. And we may have to tweak these in the future. It's fine if we do. And we'll say y1 equals source y plus height over float font height. Cool. And then we will say texture coordinates 0 equals new vector 2f. We'll do x0, y0 for now. We may have to change these too, and that's fine if we do. We'll say vector 2f x0, y1, texture coordinates 2 equals new vector 2f x1, y0, and then texture coordinates 3 equals new vector 2f x1, y1. Sweet. So now we have texture coordinates calculated. And like I said, we may have to do this again in the future, or change these up sort of the order, which is perfectly fine if we do. Anyways, let's go back into here, and now we will give this width and height, which is the font width and the font height. Remember that. And so now that we've calculated the texture coordinates, we'll also go ahead and say g2d.drawString, and the string we'll draw is this plus, and what we'll do is we'll just cast I to a char. This may give us problems in the future, but for now, we'll do it like this, and we'll see if we need to change this. And then for xy, we can just do character map dot get I dot source x, and let's actually just cache this real quick. We'll say character info, or char info equals, and then paste that. Then we'll just say info.calculate texture coordinates, and then this will be info.sourcex, info.sourcey, info.width, info.height. And that should be good. And it looks like I was mistaken. We don't actually have to provide the width or the height, so we can just get rid of those. Okay, so now we basically draw every single character that is available to this buffered image. So once we finish drawing everything, we can just say g2d.dispose, which will dispose of the graphics context, but the buffered image will contain all of that data still. And then what we're going to do for now is we'll say try file equals new Java, or we'll just say new file. Java.io is fine. And then I'm going to call this temp.png. And then we're going to say image io.write. We're going to write the image data, which is imga, the buffered image. And then we're going to say PNG is the format we want to write, and file is the file path that we want to write to. And then we will catch an IO exception because we have to. And we'll call that E, and then we'll just say e.print stack trace, or actually we'll just print the stack trace if we have an error. And then that should be good. So now if we run this, if we go to main and we say, let's create a font, C font equals new C font. And this takes in a file path. So I'm going to go C, Windows, fonts, Arial.ttf. You might have something different. And I'll do 64 for the pixel size. And this should generate an image. Shift F10. And this image should contain all of the glyphs that we need. So build successful, it ran, it did not give us an error. Let's see if we actually got an image. So if we go to our project root, we do have a temp.png. And if I open this up, it does look like we got every single character except, and here's exactly what I said we were trying to avoid, which is it's super long and narrow. That's not what we want. So what did we do wrong? What did I do wrong? If we go back to here, sure enough, what I did was I had font size being multiplied on the inside of the square root. Don't do that. That's not good. Multiply it on the outside of the square root, then add 1. And if we run this one more time, then we get the appropriate square-ish image. It's not going to be perfectly square, but it's going to be much better than what you just saw there. So if we do this one more time, there we go. You can see this looks way better. And it looks like we are actually getting cut off at the bottom here too. So I think what is happening with that is we just need to go ahead and say height plus equals font metrics dot get height times 1.4f. This is just for that last row, and then I believe that should be good. So if we run this one more time, and then we go ahead and take a look at this. There we go. Okay, cool. So then we get every single character, or every single glyph that is available to draw inside of the Arial font. And you'll notice they're all spaced out right next to each other. This might pose a problem when we're sampling later with floating point precision error, and we might have to space them out a little bit more. But this is pretty good for me. And, you know, they're pretty tightly packed. This could definitely do better. There's a lot of empty space in these vertical parts, but I'm fine with that. If we look at the file size itself, we can see that this is 598 kilobytes. So that's definitely a pretty big chunk of memory for this relatively small texture, which is one of the reasons we'll be taking a look at the other textures in the future too, because we can shrink this pretty significantly. Anyways, though, that is it for the first tutorial, guys. In the next tutorial, what we're going to be doing is actually creating an OpenGL window and then drawing fonts to the screen using these font metrics. So I'll see you guys then. I hope you enjoyed this. If you did, please hit like and subscribe, and I'll see you guys soon.